a brief way. CPU we known as Central Processing Unit. So, what is the work of it is that processing some uh, computational level of work, which is numerical. Okay. So, most of the time, our computer can handle all the process which is handled by the CPU. But sometimes, which is uh, related to binary data, ones, zeros. Uh, if you had idea about the gate, that is and or not, so you can understand how the processing of process by the CPU. So these are the simplest term we will discuss. You can see here. These are the logical function: AND gate, OR gate, and NOT gate. So these combination of these gates are creating some architecture which is in built in into the processor. Okay, so each processor has a bit, that is 32 bit or 64 bit. So at a fraction of second, it can process such amount of process. So uh, we have to understand how CPU is working and how GPU is working, which is not more than mandatory thing in to learning the neural network. But if you have idea how the CPU works and how GPU works, so when it is required, so we have to configure it. When we see in the Google Colab, we have to select the GPU and CPU. Okay, so it's depend on what level of task, what amount of information you are processing through the processor. So in CPU, you can understand that translate that information into software, graphics, animation, every other processes executed by the computer. So which is converted into one or zeros. Okay, combination of one and zeros is the just converting all the human level language to the binary level. Okay, binary level means zero and one. So processor can just process the binary operation. So you can understand uh, whenever we want to do any task, either we have to select yes or no. Okay. So just like that, computer is going to work on that basis. That is one or zero, which is we have to do either or or. That means if we understand AND gate, that means one plus one is, that means adding two information, 1 plus 1 or 1 plus 0 or 0 plus 0 or 0 plus 1. Okay. So in this OR gate, it's adding the two bit. And in AND operation, it's just multiplication the bit. And not means just negation, just opposite of. If it is 1 not, that means 0. If 0 not, that means 1. So this way, some basic arithmetic operation is done in the CPU. Okay. So what are the advantages? CPU has more flexible and resilient uh, to handle the variety of tasks outside the graphics processing. Okay, not the without graphics. That means imaginary data. That is, if we want to process image data, so it may some lagging or uh, taking more time, because we had known that uh, bitwise of operation is the numerical analysis. That means numerical processing, and graphics is non-numerical processing. So CPU is known as for parallel processing or numerical level of processing. Okay, but not for graphical processing. So uh, if you want to, we can understand by that serial processing capabilities. Okay, so CPU can multitask across multiple activities in your computer. Right now we are opening the browser in the back end, Zoom software is running, my webcam is working, my audio is working. So parallelly, lots of processing is happening in the CPU. Okay, so it is divided by the priorities. Which process or which task should be high priority. So right now we are opening the browser and we are opening the using the Zoom meeting. So two software are we are using, but in the backend, the supporting device is uh, webcam and audio. Okay, so these four processing tasks are getting more priorities in the processor, and other are getting low priority. So using priority from uh, priority value, the CPU is just dividing the processes. So which task is important? Because in the RAM, we have to run, we can just use one single software, okay, to run at a time. Because if we want to use CPU, we have to do like that. Because CPU can understand the bit operation. Okay, so right now, if we are opening this browser and this we are using PPT, so all the pixels are converting into 0 1, and serial of 0 1 is getting processed by the CPU. Okay, but if we want to process some image data, so GPU can handle more uh, in a more fast way, in a good way. Okay, than CPU. So in the you can see that in the contextual power, CPU will outperform the GPU because CPU is significantly faster for handling such system operation. Random access memory, that means RAM, mid-range computational operation, managing and operating system, input of output operation. Okay, so these are the basic operations which is CPU can handle better than GPU. Okay, so in precision level, CPU can work mid-range mathematical equation with a higher level of precision. Okay, because if we want to do some programming, so program will convert it into a human level language program. That means Python, C, C++. It will convert it by some instruction. Instruction will convert it into bit 0 1 combination of 0 1, and then those bit is processing by the CPU. Okay, so CPU in the we have more precise than GPU. Okay, because GPU is just depend on how which level of graphics we are using. Okay, so it's different architecture. We had seen in that the NVIDIA, AMD. These are the well-known companies. They are making GPU. Okay, so both are processing the data. Okay, but it's the difference is CPU is for linear processing and GPU is for non-linear processing. Okay, linear processing means we have numerical data. Okay, and GPU means GPU are non-linear. That means they have some uh, different type of data. That means it's a color code and something which is non-numerical. Okay, so which is always non-linear. That means we cannot uh, plot the non-linear data into a single uh, direction. That means upward or direct and downward. But if you had idea about linear regression, so you can understand whatever I'm saying. Okay. So access to memory. So CPU is more uh, able to handle memory means not only RAM. We have some cache memory also, which is between the RAM and CPU. Okay. So whatever task or the data we are fetching from hard disk, which come into the RAM, and then from the RAM to CPU, a very small amount of memory are set up there, which is known as cache memory. Okay, which is always 3 MB, 2 MB. 5 MB, 8 MB, okay, 16 MB. Uh, so it's not a high amount of memory, but they are just using for fast processing. Okay, so CPU usually contains significant local cache, which means they can handle a larger set of linear instructions. Got my point? Linear instructions, and hence more complex system and computational operations. So we in the comparison of cost and availability, CPU is more readily available, which is less cost than GPU, more widely manufactured and cost effective for consumer and enterprise. So hardware manufacturers are still creating thousands of motherboards designed to house a wide range of CPU. You can understand for i3 to for I uh, up to 9 is out, and currently 13th to 14th generation is running. Okay, so they are just upgrading the processes. Okay, how they can multiple processes can be handled by the CPU, and even some image data also can handle, but not high definition level of graphics. Okay, so we have to convert it into the numerical data. And then numerical data will be converted into bit, and then the bit will be converted into signal, positive and negative. Okay, and then it's processes through the process. So disadvantage of CPU is parallel processing. CPU cannot handle parallel processing like a GPU. Okay. So large tasks require thousands or millions of identical operations. Okay. So it will choke or hang the CPU's capacity to process data. That's why whenever we are processing high level of graphics, that means in a fraction of second, 10 high definition of images are processing. So it will not able to handle those tasks. Okay, because each pixel's color code converted into some numerical data, and then those numerical data are converted into bit, and then those bit will be processing forward. So uh, what are the reason to slow evolution? There is some mathematical law, which is mathematician was Moore's. So Moore's law, in line with Moore's law, developing more powerful CPU will eventually slow. Okay, which means less improvement year after year, because processing vast amount of data, we have to create more bit. Okay, so we have to make some cost-effective processor also. So that's why if we are increasing handling more uh, uh, powerful CPU, so it will get more costlier. So will not be able to buy some all almost all processor. So we are just checking that which is a cheaper laptop or which is low cost. So that's why we have to just process with the 64-bit operating system or 32-bit, but more effectively, because which is more important and which is more important to process. So that process or that task will get more priorities at that time. Okay. Now in the compatibility mode, you can see here every system or software is compatible with every process. For example, application written for 86. This is the 32-bit. Okay, where we can see x64-bit. That means that is 64-bit architecture. Here x86 means it is 32-bit architecture. Intel processor will not run on ARM processor. Okay, so ARM has some full form of advanced RISC machine. Okay, what is the meaning of RISC? Reduced instruction set computer. Okay, so this is the logic or the architecture of this processor. Okay, So this is less of a problem as more computer manufacturers use the standard processors. Okay, like Apple move to Intel processors. Okay, and but it still present some issues between PC and mobile devices. So these are the compatibility. You can see that whenever you install some software into your 64-bit operating system, it will not say that what is the compatibility. If you have Windows 7, so most of the software right now are developed for Windows 8 or Windows 10. Okay, so it will always told you that just change the compatibility. Okay, if we go to the any software like Joule, okay, if we right click on it and you can see here, if we go into the properties, okay, so we can see here compatibility tab. Okay, if we click on it, you can check here the window 8. If we want to run into compatibility mode, we have to click on it. So we can change it according to the operating system, Windows Vista, Windows Vista Service Pack 1, 2, 7, 8. If I have installed Windows 11, so here we can see Windows 8.1, Windows 10, and Windows 11 also. Okay, so it's depend on which compatibility mode we want to run that software. Okay, so we can check here. It is the high DPI setting, more complex setting are there. If you can see then the very previously CRT monitor, these resolutions, if we check it, okay, you can see here 60 to 614 to 480. Okay, but if we go into our current screen resolution, so you can see here. Here you can see 30, 1366 into 76, 706. So this is the length and width of the uh, this screen. Okay, that means multiplication total sum of this uh, number is the total number of pixel in this system, in this computer. Okay, so in the previous computer and the CRT monitor or something, so they have very less level of resolution. That means if we are opening this PPT, so our PPT is opening into 1366 into 76 8 pixel. Okay, if we are opening it into a very large display, so the processor have to process more. Uh, they will get more data. Okay, because we have to the processor have to process the all pixel. Okay, so our view of any software or any document, whatever we are using, so the display should work like that. So these are the differences in the CPU and GPUs. GPUs are processing unit. Okay, so it's a graphics processing unit, and mainly it's inbuilt into the computer games, because games are just uh, the very high level of high definition images processing. Okay, at a time the object is moving. If we are playing some firing game, so the object is moving in a fraction of second, 10 to 15 moves. Okay, so in a second, it may have to process 10 to 15 or 20 images. Okay, so that is the more, it's just creating more data to processing. Okay, that's why graphics processing unit is basically developed for gaming or processing some uh, uh, software which is developed to process uh, images. Okay, like Photoshop. Okay, so it has some high throughputs to allow faster performance in gaming. Okay, GPU requires more ALU. ALU means arithmetic logical unit. Okay, which is also into the CPU. Arithmetic logical unit is the main part of the process because all the process are numerical. All numericals are related to arithmetic. Okay, arithmetic linear logical unit. Okay, so this is the simple definition of GPU. Uh, it has some it requires devices to perform high-end graphics processing. GPU contains own RAM. Okay, uh, one RAM is for CPU and another RAM for GPU. Okay, so which is known as virtual RAM or video RAM, you can say, because most of the time this RAM is mounted by the free hard disk space. Okay, if we go into the mount section of the hard disk, we can see that even you can buy today's smartphone, so they can say in the specification that 16 GB RAM, dynamic RAM. That means 12 GB RAM is inbuilt for processing linear instruction, and 4 GB is extra, which is use the internal memory of the phone or the computer hard disk when the graphics processing is required. Okay, so both RAM are different. Okay, and the GPU is just reserving those spaces from the hard disk. Okay, to process the graphics. So the advanced GPU system work cooperatively with the multi-core CPU. Okay, multi-core CPUs and modern GPUs are much more than GPUs. Uh, Modern GPUs are most widely used for gaming research and analysis tasks. That means today, whatever we are learning, computer vision analysis or some NLP related. So these processing are more uh, means complex than the normal numerical process. Okay, so advantages of GPUs is high data throughput. Uh, GPU consists of hundred of cores performing the same operation on multiple data items in parallel. That means we are just dividing a single task into multiple tasks, and multiply uh, they are just getting putting into the processor togetherly, and then after processing it will just combine. Okay, you can see that we are dividing an image into multiple neurons, and all the neurons are processing through the nodes. Okay, so now you can compare the theory and the logic. So these are the things we are just dividing all the pixels of the images and passing through the nodes. Okay, so these are the way of architecture of GPU to process the high level of amount of data. So GPU can push vast volume of processed data through a workload, speeding up specific tasks beyond CPU. Okay, so it's have massive parallel computing. CPU are more excel in good in complex computation. Okay, if we are processing some numerical analysis, some programming, and some that means if we have numerical level of analysis of it, so CPU is good. But if we have image, multiple uh, bit information stored into the image, that means 4K images, 8K images, and some uh, means black and white images. So different types of images are we are processing. So it's the information behind the images are different. So processing those information properly, and we have to use GPU. Okay, that is the modeling complex system, and computing matrices because if we calculate some numerous similar operations, so GPU is good than CPU. Okay. Uh, I think you have known about Bitcoin. Bitcoin is just a part of cryptocurrency. Okay. So cryptocurrency is the digital currency. What is digital currency? Uh, you can understand that by uh, why when we transact amount by when we are purchasing something, we are just transferring some amount to the seller. Okay. So what is happening here? We are just doing some transaction. Okay. So those transactions have some unique ID, and those unique ID are maintained into some digital ledger. If you know about some commercial term, commerce. So you know about that ledger. Ledger means a bahi khata. So in this world, in even into a single fraction of second, how many billions of transactions are happening continuously? Okay. So how to identify these transactions are unique or not? So these transaction analysis of those transactions uniquely and identifying by some hash code. Okay, that is if you are paying something through the Paytm to the seller, you can see there is some transaction ID. Okay, so those ID are unique in the whole world. Okay, at that time. So maintaining those transactions by some unique ID in billions and trillions of transactions of the world is the digital currency. Uh, so that is the uh, uh, cryptocurrency. Okay. So we have to mine those data. Okay. Mine those data that how many transactions are happened and that means if someone if we can see the example of share market. So lots of purchaser are purchasing the shares and selling in a second minutes. Okay, so we have to maintain those transactions for the final calculation of the company profit and loss. Okay, so for that this cryptocurrency is uh, developed for just identifying those transactions by some applying some cryptography. That means some uh, decode input. That means we are just hiding those values by some uh, uh, by some different level of code. That means we are just hiding the actual text. Okay, actual transaction. So only the buyers and the sellers can see those. And even there is some crime or something happened, then the government only can check those uh, uh, code. Okay, so these coded are maintained into some hashes. Hashes means some number like 1, 2, 3, 4. This is called complex cryptographic hashes. So you can understand that how many billions, trillions of transactions are happening. All the IDs should be unique, must be unique. Okay, so those uh, processing, uh, those IDs are processing is known as Bitcoin mining. Okay, so for that we have some high level of information. So that's why we have to use GPU to process this Bitcoin mining. Okay, this is the very uh, high level of paid service. Okay, if someone is want to go into this Bitcoin mining, like you heard about data mining. Okay, but here it is Bitcoin mining. So the increasing expansion of Bitcoin and the difficulties of mining Bitcoin has led Bitcoin mines to implement a GPU to handle immense volume of cryptographic data in the hopes of earning Bitcoins. If you go to the Google and just type uh, Bitcoin mining GPU, so you can see that what level of processor are required. You can see here. Okay, this is the YouTube image. So these are the graphics card, and they are all connected, parallelly connected. Okay, to process the same task parallelly. Okay, so this is the simple thing. Even this a single graphics card may be of 6 GB, 16 GB graphics card, 32 GB graphics card. Okay, so you can see that how much you can see here. More these are the they are the Bitcoin miner developer. Okay, so they are just making some set of graphics card to process the Bitcoin. Okay, so it is very high paid job in today's market, but most of the time it is very costlier, so nobody is interested in this thing. So we have to just check those things side by side. So we had heard about machine learning. Neural networks, particularly those used for deep learning, so where we use GPU, function through the ability of process large amount of training data. Okay, through smaller nodes of operation. And GPU for machine learning have emerged to help process the enormous data sets used to train machine learning algorithm and AI. So we are just teaching the machine how to learn using the data. Okay, so we have to process more data at a for a analysis to get a better result, to give more knowledge to the machine. So we have to process lots of data. If we have millions of data, so it can learn more effectively. If we have billions of data, so the machine can learn more than, so we have to, whatever we have the data, we have to process the high amount of data to train our machine learning. That's why GPU is required.